Okay guys, so once again, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. Sorry for little inconvenience, little audio issue was there, but now yes, it seems a green signal. It's good to go guys, and let's get started with this important session, that is the electromagnetic theory. And guys, in any of the competitive exams, especially BARC, ISRO, HAL, DRDO, all the government exams, EMT plays a very vital role. It has a good weightage, and especially the topics of antenna and waveguides also cover up a lot of questions in these examinations. So let's get started and let's keep on learning and revising the questions based on them. So guys, in case if somebody new to my session, this is a brief intro about me. This is your mentor and educator Rakesh. I have secured All India rank 9 in the GATE examination, completed my masters from the Indian Institute of Science, Bangalore. Having trained more than 50,000 students in my more than 11 years of journey, I commonly deal with control systems, digital electronics, EMFT, signal and system, and also in the non-tech area, I deal with the mathematics and aptitude guys. Yes. Okay. So join the Telegram group GATE/ESE by Rakesh Talreja if you want the PDFs of the session. Like yesterday I shared you the PDFs of control, both the PDFs of control system I shared. Right, good evening all. Keep joining the session, keep updating your friends. The session is now going on live. Okay, whatever we are discussing in the EMFT also today and tomorrow, there are the two parts again of the EMFT. So there also you will be getting the PDFs in this particular Telegram channel, and other than that, doubt discussions and notifications of different classes you will definitely get from here. Let me give you a quick update that mastering GATE concepts. Yes, those who want to prepare for the upcoming GATE exam, maybe your friends, colleagues or juniors are looking for the GATE 23, GATE 24 preparation. So BYJU'S Exam Prep brings a fresh series, Mastering the GATE Concepts, which will be offering you the concept, the complete subject analysis first of all, to begin with what that subject is and how much is its weightage and all in the exam. Then it will focus on the conceptual clarity. Okay, the most important concepts of the subject to be taught by the expert faculties, supported by problem practice and previous year questions, and the subject to be concluded by live mentee quizzes. Okay, so you have 1-to-1 quiz live on the YouTube. This is the schedule. This is how it is going on for different branches. Different slots have been there, so you can see ECEE network theory. Since today is Tuesday, there will be guys, you are all ECEE students, especially today is EMFT, all EC students are there. 10:30 p.m. is the session time for network theory. You can watch live by Sanjay Rathi Sir on the same channel, so do not forget to subscribe in case you are missing it, right? Chalo guys, and also guys, those who want, these are the classes for GATE 23, but if you want the in-depth strategy analysis for the GATE 23 preparation, how to conquer it, so a workshop on the app. Okay, this is a workshop event that is going to come live on the BYJU'S Exam Prep app. This is not on YouTube, to be taken by your favorite Abhinav Negi sir, who has more than 10 plus years of experience and is a IIT Delhi alumni, and this goes live on the 13th March, that is a Sunday at 12:30 p.m. Yes guys, good evening. So this is the first question guys. Now let's quickly start with the question discussion for the day. Right, if the electric field intensity E is given to you, what is the potential difference between the points X and Y? What is the potential difference between the 2 points X and Y? Let's have a hold of this. What is the potential difference between the points X and Y? Okay, the question is asking you Vx minus Vy, where the coordinates of X and Y are of course given to you. The coordinates of the X and Y are given to you. So what should be the value of Vx minus Vy? So try to recall, how do you write down this actually? Okay, when you want to discuss the potential difference between the points A and B, we usually write down VAB, that is given by VB minus VA, and that is evaluated as negative minus integral minus of the integral A to B E dot dl. That is negative of the integral A to B E dot dl. Right, VAB is VB minus VA, negative of the integral E dot dl. Acha. Right, now, what is the value of electric field that is given to you? You want the value of Vx minus Vy. You should want the value of Vx minus Vy, or this can be written as Vyx. right? Vyx, like VAB is VB minus VA, Vx minus Vy should be Vyx, and this is equal to negative of the integral from y to x a to b E dot dl. Okay, so this is then equal to negative of the integral E dot dl, electric field dot dl. When you do, you are going to get x dx, y dy, z dz. That's it. Okay, what is the integral of x dx? Is x square by 2, y dy y square by 2, z dz is z square by 2, because clearly all the terms are independent. I mean, x with dx, y with dy, z with dz. There is no mixing of the function. So the x square by 2 plus y square by 2 plus z square by 2 is the answer of the integral. Now we put down the limit, that is the limit from y to x. The limit from y to x. What is the point y? The y point is 1, 2, 3, and the x point is given to you as 2, 0, 0. Okay, so this becomes minus of 1 by 2 outside. Upper limit put kiya, so that is 2 square. Lower limit if I want to put to 1 square plus 2 square plus 3 square, and this is going to be minus of 1 by 2. 4 and 4 cancel, minus of 10, minus cancel, answer is the 5 volts. The correct answer is option number C, that is the 5 volt. Okay guys, everyone? Correct guys, 5 volt is the very correct answer. Moving ahead to the next question. A potential field is given by phi is equal to 2xy square minus 3y square z. If x, y, z are the unit vectors along x, y and z directions respectively, then find the field intensity at 0, 1, 0. Find the field intensity at 0, 1, 0. Okay, the potential field is given to you 2xy square minus 3y square z. Okay, now in this case potential is given. Previous question electric field is given and you are finding the potential. Now what is the field if the potential function is given to you? So electric field is given by negative of the gradient of V or negative of the gradient of phi. The field here is the potential is represented by phi. So minus grad phi. This is what is the formula that you will be using here. Okay, so let us use this one quickly, and you are going to get the electric field as equal to negative of the gradient of phi, and the gradient formula it's in Cartesian coordinates, so it is simple. Del phi by del x, del phi by del y, gradient formula, I'm sorry. So this is going to be minus of ax del phi by del x plus ay, gradient formula, del phi by del y plus az del phi by del z. Okay, so this is negative of, now del phi by del x. Del phi by del x, what should be the del phi by del x? Differentiation with x becomes 2y square. Okay, then plus ay. What is the differentiation with y? It becomes 4xy minus 6yz plus az. What should be the differentiation with z? Minus 3y square. Right, and now we need to calculate this value at the point 0, 1, 0. So at the point 0, 1, 0, the electric field is turning out to be negative of y ka value 1 hai, so this becomes the 2ax. Then you are able to see x is 0, z is 0, so the second term is 0. Third ki baat karenge to y ka value 1, so this becomes the minus 3az. Take the minus inside, so the answer is minus 2ax plus 3az. Minus 2ax plus 3az. Option number C should be the correct answer. Yes. No, Narsima, it's C. Just check it out once. Yes, Ashutosh, correct. Correct answer is the C. Everybody. All cool. The correct answer is option number C. The correct answer is option number C. Moving ahead to the next question. Moving ahead to the next question. A total charge of 90 microcoulomb is split into 3 equal charges located at 120-degree interval around the circular loop of radius 8 meter. What is the potential at the center of the loop? It's a good question. What is the potential at the center of the loop? Right. Thank you, Abhishek. Okay. So guys, let's take up the picture. Let's take up the picture given to this. A total charge of 90 microcoulomb is split into 3 equal charges located at 120-degree interval around a circular loop of radius 8 meter. So circular loop ले लिया है, and now I need to place at 180 degree, 120 degree. Okay, मतलब approximately if I place, this can be the situation. Let me also mark up the center. This is the center, and let us mark up these distances. So suppose one of them is here. I'm just joining all of them with respect to the center. Okay, now let's suppose the total charge 90 microcoulomb is split into 3 equal charges. So what is the 90 divided by 3 is equal to 30 microcoulomb, and suppose this is equal to Q. Suppose that 1/3 of the charge I call it as Q. So this is a charge Q, this is the charge Q, and this is the charge Q, right? We want the potential at the center of the loop. So what is the formula for the potential, guys? What should be the formula for potential? Potential due to point charge at any point P. So the potential at the point P, because potential is a scalar quantity, it is simply given by the formula KQ divided by R, or where K is given by 1/4 pi epsilon naught. Free space and nothing is mentioned to free space, so epsilon is epsilon naught. 1/4 pi epsilon naught Q by R, right? What is the Q? Q is the value of the charge, and what is the R? Distance. Okay, what is the R? R is known as the distance of the point of observation from the source charge. From what? From the source charge. Distance of the point of observation from the source charge. Okay, that is what is the VP. That is what is the value of R. Okay, so now all the 3 charges are equal and all the 3 distances are also equal, because we are finding the potential at the center and the charges are at the circumference. So all of them are equidistant from the center. The distance from center to circumference of a circle is fixed, that is equal to the radius of the circle. So if I want to calculate the total potential at P, okay, if I want to calculate the total potential at P, this is generally, I want to say that this was the formula for potential. Now if I want to calculate the total potential at P, the total potential at P is equal to the same formula to be applied 3 times. The same formula to be applied the 3 times. Okay, so just let us calculate. What is the value of K? The value of K, after putting the value of epsilon naught, the K is 9 into 10 power 9. So let me put this value 9 into 10 power 9, right, multiplied by Q, which is 30 microcoulombs. 30 into 10 power minus 6, and then further multiplied by 3 is whole divided by the R, and R is known as the radius, which is equal to 8. R here means the distance, which is the radius, and that is equal to the 8. Just complete up this calculation and write down the answer. So how much it is going to be? 9 into 3 into 3, 81 is divided by 8 into 10 raised to the power kitna? 10 power 3, 10 power 4, right? So approximately the options are in the form of kilovolt. Kilovolt में convert करने के लिए you can write it as 810 into 10 power 3 volt, right? For the BARC you can use virtual calculator. For HAL you can do the manual calculation, and it is very clear that it is approximately cancelled at 101 times, right? So this is approximately 101,808 से cancel किया kilovolt, that's it. So correct answer is option number B, that is able to match here. My screen is off, just allow me 1 second. Okay guys, any doubts please keep on asking me. So the solution is simple, but little bit just geometry you had to handle here. Okay, just little bit of geometry you had to take care. Yes. Okay. Chalo, moving ahead to the next question. Okay. Moving ahead to the next question. 2-point charges Q1 and Q2 are placed at a distance of B, and B equal to 1 centimeter, A equal to 10 centimeter from the origin on the y and x axis as shown in the figure. The electric field vector at the point P, AB, that will subtend an angle theta with the x axis. That angle is given by how? The tangent of the angle is given by what formula? You have to calculate the tan theta. You have to calculate what? You have to calculate the tan theta. So देखो, there are 2-point charges Q1 and Q2. Okay, just try to understand that this is an electric field question, and electric field is given by what formula? Electric field due to a point charge is simply given by the formula KQ upon R square AR, where AR is the unit vector in that direction. AR is the unit vector. Yeah, this can also be written as KQ by R square into vector R divided by R. What is the vector R? What is the vector R? It is the vector from the point charge. It is the vector from the point charge to the point of observation. To the point of observation. So what is the AR? If you want to discuss the AR, AR is known as the unit vector. Unit vector along R, and the definition of unit vector is the vector divided by its magnitude. Okay. Now, if this is the basic formula for the electric field, the question says that the total electric field at the point AB will subtend an angle with the x-axis. What is that angle given by? What is the tangent of that angle given by? Let's have a look into this. Okay. Now, it is very clear that what is the electric field due to Q1? Okay, let us draw this diagram here. I'll introduce this P also. Well, let's make a simple diagram here. Everybody, just try to focus. Okay, just try to focus. Let's take a fresh diagram here. Okay, so there is the charge Q1 which is at a distance B. Okay, this is the charge. This is known as the charge Q1, and this is known as the charge Q2. Okay, this is B and A. B is 1 centimeter. This is B, which is 1 centimeter. This is A, which is 2 centimeter. I am interested at field at the point P. Now, field at the point P, the field due to the point charge will be radially away from that point charge. So, consider this point. This is the point P, which is A comma B, and this is the electric field. This is the electric field E1 due to the charge Q1. This is the electric field E2 due to the charge Q2. Okay, and this was the point P, which is A comma B. Now, what is the net electric field, guys? The net electric field is the superposition vector sum of both of them. So that is known as the E1 plus E2. The net electric field is basically given by E1 plus E2. Now, what is E1? E1 is actually along the x direction, you can say. E1 is the electric field which is along the x direction. So I can say this is known as the electric field along x. Electric field E2 is totally along the y direction, parallel to y axis. So E2 can also be written as EY, EX plus EY, right? EX plus EY. So basically just the simple logic you can apply is resolution of the vector. Try to apply what? Resolution of the vector. As per the resolution of the vector, we know that modulus of EY is known as the modulus of E, modulus of EY, the vertical component, mod E sine theta, and what is the modulus of EX, horizontal component, is known as the mod E cos theta. Mod E cos theta. Right. So when you divide, you are going to get the tan theta. So when you want to discuss the tan theta, which is known as the sine theta divided by cos theta, and that will be obtained, mod E cancel, that will be obtained as modulus of EY upon modulus of EX. Now what is the modulus of EY? Let us write down the answer. What should be the value for tan theta? The tan theta is given by modulus of EY. What is the modulus of EY? What is the magnitude of EY? The magnitude is given by, for electric field, if you want to write down only the magnitude term, so that is the KQ by R square. KQ by R square. So this will be given by K Q2 divided by R. R matlab distance. So ये distance कितना है? B. So this is B square divided by K Q1 divided by modulus of EX. So what is the magnitude of EX? K, the charge Q1 divided by distance square divided by A square. So K2 K is getting cancelled. You should solve Q2 by Q1 into A by B ka whole square. A goes above. What is the value of Q2 and Q1? Now place the value. Q2 is 1 microcoulomb. ये है 1 microcoulomb. Q1 is 2 microcoulomb is multiplied by A by B. A is 2 centimeter and B is 1 centimeter. Right, centimeter cancel, micro cancel, 2 square by 2, answer is 2. So the value of tan theta should be given by the 2. The value of tan theta is simply given by 2. Correct answer is option number B. The value of tan theta is equal to 2. Okay. Okay. The value of tan theta is equal to 2. Let's move ahead. Moving ahead to the next question then. The following point charges are located in air. The following point charges are located in air. There are the 3 point charges. What is the total electric flux over a sphere of 5 meter radius with the center at 0, 0? With the center at 0, 0. Okay. Yes, Chatterjee, right now the topic, maybe I'll plan some separate session for EE again, but the topics that are going right now is common for ECEE. Okay, it's common. So if you are watching, you can watch this also, because these topics, especially the electrostats and magnetostats, the question based on them is common. Okay, it is the common. Okay, so you can follow that. What is the total electric flux over a sphere of 5 meter radius? So let's make it very clear that there is a sphere of the 5 meter radius. The radius of the sphere is 5 meter. So the first point charge, that is suppose this is Q1. Okay, the Q1 is located at origin. Then there is the next point charge Q2, that is at 3, 0. So 3, 0 is inside the sphere, because radius is 5, so this should be 5, 0, and this is here 3, 0. The radius is 5, so this point is 0, 5, and the next charge, suppose that is the Q3, is at 0, 4. So Q3 is also inside. Okay. Now what is the total electric flux over the sphere of 5 meter radius? What is the total electric flux over the sphere of 5 meter radius? Okay, so the total electric flux, basically to be determined by Gauss law, and what is the total electric flux according to it? The total electric flux over any closed surface is given by the charge enclosed. For closed surface. Okay, we know that Gauss law is applicable only for the closed surface. It's applicable only for the closed surface. So xi is equal to the Q enclosed. Correct. The xi is equal to the Q enclosed. Right. Okay. Now, how many charges are enclosed? Actually, all the 3 charges are within that closed surface, within that sphere. So basically, it is Q1 plus Q2 plus Q3. Okay, you just have to solve up the calculation, guys. You are going to get the answer. Addition is up to you. Just add all of them with the proper signs of them. The correct answer is going to be B, 0.049 microcoulombs. You will solve and you will get that answer. Okay, sure. Now another version of Gauss law, okay, which we also call it as the Maxwell's equation. Let D is equal to 8 rho sin phi A rho plus 4 rho cos phi A phi coulomb per meter square. Find the volume charge density at the point P. Volume charge density, rho V, another version of the Gauss law only, or also stated as one of the Maxwell's equation. Rho V is given by del dot D. Divergence of D, rho V is given by del dot D. Okay, now what should be the formula for del dot D? Now this vector D is given as rho phi. Rho phi means it is in the cylindrical coordinates. ये भी ध्यान रखना पड़ेगा. It is in the cylindrical coordinate, guys. Okay, so the vector that is given here is in the cylindrical coordinate. So what is the formula for divergence in the cylindrical coordinate? Rho V, which is del dot D. The formula in the cylindrical coordinates for divergence is given by 1 by rho del rho of rho d rho, that is the rho component, plus 1 by rho del phi del by del phi of the phi component है क्या यहाँ पे? Yes, del by del phi of the phi component plus del by del z of the z component. That is as simple as that. Okay, now place down the values and get the answer. So what should be the value of rho v? 1 upon rho del by del rho of rho d rho. D rho means the rho component of the vector, which is 8 rho sine phi, which is known as the 8 rho sine phi, plus 1 upon rho plus 1 upon rho del by del phi of d phi, that is 4 rho cos phi. 4 rho cos phi. Okay, chalo, plus del by del z of dz, and there is no z component, plus del by del z of dz, but there is the no z component, and hence the dz is equal to what? The dz is 0. Chalo, no issues. So what should be the value for rho v? 1 upon rho square ka differentiation, rest will be constant, so that is 2 rho, so this becomes 16 rho sine phi, plus 1 by rho del by del phi. Now what is the differentiation of cos phi? Minus sine phi, so minus 4 rho sine phi plus the 0, guys, and this is equal to rho to rho cancel, 16 sine phi minus 4 sine phi, so answer is actually 12 sine phi. Now we need the value at the point 2.638 degree and minus 6.1. So this is what is the value of phi that you need to use here. So this is going to become 12 sine, how much is the degree? 38 degree. 12 sine 38 degree. Yes guys, close the answer. Okay, turning out to be 7.38. 7.38 या 7.39. perfect. Option number A. Volume charge density, charge per unit volume, coulomb per cubic meter. Coulomb per cubic meter. Okay, so that is the another version of Gauss law, also known as the Maxwell's equation. The volume charge density rho v is given by the divergence of the flux density vector, that is del dot d. Okay, that is known as the del dot d. Okay, chalo guys, great. Moving ahead to the next question. Okay, the next question is based on a capacitor. The capacitor consists of two plates, each 500 cross 500 mm square and spaced 6 mm apart. The space between the metal plates is filled with a glass plate of 4 mm thickness and a layer of paper of 2 mm thickness. The relative permittivities of the glass and paper are given to you. Neglecting the fringing effect, what is the capacitance of the system? Now the capacitor consists of two plates, each 500 cross 500 mm. That is the each 500 cross 500 mm. Okay. So plate area of both is given to you. Let's draw this first of all. Okay. This is total separated by 6 mm. Okay. The plate area that is given to you is 500 cross 500 mm square. If I want to simplify, this is 25 into 10 ki power minus 4 into mm square. Mm is 10 power minus 3, so mm square is 10 power minus 6. So this is basically, this is 10 power 4 tha, so this is 0.25. This is 0.25. Acha. Now the space between the metal plates, okay, total separation is 6 mm, but this separation, the space is filled with a glass of 4 mm thickness and a layer of paper of 2 mm thickness. Okay, so up to the 4 mm thickness you can say that there is the glass, so there is a different dielectric. Okay, this is glass for 4 mm thickness and a layer of paper. So because of two different dielectrics, it will offer the two different values of the capacitance, and this is 2 mm. This is 2 mm. The relative permittivities of the glass and paper are 8 and 2. So relative permittivity here is 8. The relative permittivity here is 2. Okay. Neglecting the fringing effect, what is the capacitance of the system? So what is the equivalent diagram? Okay, we know that the capacitance is basically given by the formula for parallel plate capacitance. The capacitance is epsilon s divided by d. The parallel plate capacitance is given by the formula epsilon s is divided by the d, right? So So because of the different permittivities and even the different plate separation, you have different capacitance. So let's say the capacitance of the glass region is C1, and for the paper region, suppose that is the C2, and clearly they are connected in series with each other. Okay, so what is the equivalent formula for series capacitance? It should be C1 C2 is divided by C1 plus C2, where the formula for C will be epsilon S divided by D. Just come on, quickly complete the calculation, guys. Let me again check up with my screen why it is going off. Yes, do it up quickly, guys, everybody. Okay, chalo. Yes, guys, anybody with the answer? Okay, so let's calculate this. So what should be the value of C1 and C2? The C1 will be epsilon 1 S, the plate area is common to both, divided by D1. So what is the value of epsilon 1? It is equal to 8 epsilon naught into 0.25 divided by the separation. This is 4 mm. 4 into 10 power minus 3. So this is 2 into 0.25 is 0.5 into epsilon naught. 0.5 into 10 power 3 ho jayega. That will become 500 epsilon naught. Okay, then what is the value of C2? It is epsilon 2S divided by the D2. That is equal to 2 epsilon naught, plate area same has 0.25 divided by the D2, that is 2 mm. 2 into 10 power minus 3. So this is equal to 0.25. ये आ गया 0.25 10 पावर 3 ऊपर गया तो 250 epsilon naught. 250 epsilon naught, right? So what is the C equivalent? That is C1 C2 divided by C1 plus C2. Solving this, you are going to get the answer as R or R by 2 जैसा केस है, तो that is 500 by 3 epsilon naught. Put down the value of epsilon naught. This is going to be 8.854 into 10 raised to the power minus 12. Minus 12 will go into picofarad. Solve it up. Approximately you are going to get it as 1475 picofarad. इसको solve कर लेना, you will get the answer as 1475 picofarad approximately. 1475 picofarad. That is the option number B will be the perfect answer. Okay, the option number B is the correct option. Moving ahead to the next question. A filamentary current of 8 amperes flows in the Z direction. What is the magnetic field at the point 0, 8, 0? A filamentary current of 8 ampere flows in the Z direction. What is the magnetic field at 0, 8, 0? Now there is a current flowing along the Z direction. So what is the length of the Z direction? It's infinity. So that is a infinite line current. Okay, this is based on what? Infinite line current, right? The magnetic field, okay, due to infinite line current is given by I divided by 4 pi rho a rho. I divided by 4 pi rho a rho. Now let me explain you this terminology. Okay, now the current is flowing along the Z direction. Okay, sir, there's a current. Suppose this is what is the Z direction. So there is an infinite current that is flowing, infinite line current that is along the Z direction. And I need to find the magnetic field at the point 0, 8, 0. So the point is 0, 8, 0 looks like on the y-axis. So there is a point which is on the y-axis, right? And that point is 0, 8, 0, right? Now this is what is the line current, I can say. How much is the value of the current that is flowing along the Z direction? The current is 8 ampere. Okay, so what is the magnetic field at this point? It is given by, as I told you, I divided by 4 pi rho a rho. Now what is the value of rho, sir? Rho is the perpendicular distance of the point of observation, perpendicular distance from the point of observation from the axis of the wire. From the axis of the wire. And what is a rho? A rho is the unit vector arrow is known as the unit vector along this perpendicular line. So this unit vector is along the y-axis, and what is the unit vector along the y-axis? It is AY, right? So now I put down the value. I is the value of magnitude of the current 8, then divided by 4 pi rho. Rho is also equal to 8, 0, 0, 0 to 0, 8, 0. So the distance is 8. So I upon 8 upon 4 pi 8 into arrow, that is AY. Answers are in the form of pi only. Okay, so 8 to 8 cancelled. Oh, sorry. Infinite line current. That is the I divided by 2 pi rho only. I'm sorry for it. I divided by 2 pi rho. Okay, so final answer that is going to come is 1 upon 2 pi AY. That is known as 1 upon 2 pi AY. 1 upon 2 pi AY. 1 upon 2 pi AY is the option number C. AX nahi hoga, AY hi hoga, that is sure. So there is some definitely corrections required here. That is going to be in the Y direction. I'm sorry guys. Maybe that mic issue today has disturbed my concentration since the beginning, I think, because 20 minutes we were just struggling with the mic issue. Okay, it is I upon 2 pi rho A phi. What should be the value of A phi? A phi is given by the formula AL cross arrow. No problem guys. The A phi is given by the formula AL cross arrow. It is given by the formula AL cross arrow. Okay, so yahan pe here also I will write down, this is the A phi. This is known as the A phi. Now, as I am telling you, what is the A phi? A phi is given by the formula AL cross arrow. Arrow I explained you. Arrow is the unit vector along that perpendicular line. What is AL? AL is the direction in which the current flows. The direction in which the current flows. So this is what is AL, right? And this AL is definitely along the Z direction. The current is flowing along the Z direction. So यहाँ पे value रखेंगे Z cross Y. Now what is Z cross Y? Minus X, because Y cross Z is the X. So Z cross Y is minus X. So now put down the value 8 upon 2 pi rho. Rho is again 8 and this is minus AX, and that is minus 1 upon 2 pi AX. Minus 1 upon 2 pi AX, that is the option number D going to come up as the answer. Right, option number D, minus 1 upon 2 pi AX. Right. So I upon 2 pi rho A phi, where A phi is given by AL cross arrow. AL is the direction in which that line current flows, and arrow is the perpendicular direction, unit vector के form में, perpendicular from the axis of the wire towards the point of observation. Okay, hope this is now clear to you. Correct answer is option number D. Moving ahead to the next question. If the magnetic field H is given to you 0.01 divided by mu naught AX ampere per meter, calculate the force on a charge of 1 picocoulomb moving with the velocity of 10 power 6. Okay, what is the force on the point charge? The force Fm, okay, in the presence of magnetic field, the force on a point charge moving with velocity V is given by what formula? It is given by the formula Q into V cross B, simply. Q into V cross B. That's a simple formula based question you are getting here. Now what is the value of the Q? The Q is 1 picocoulomb. In the velocity 10 raised to the power 6 AY. Right. What is the B field? Now B is given by mu into H. Mu naught into H, since nothing is mentioned, so we'll take it as free space, and mu naught H is 0.01 upon mu naught. So mu naught se multiply karenge. So this is 0.01. This is 0.01 in the X direction. Okay, so this is multiplied by 0.01 AX. So total kitna ho gaya? See, this is pico. Pico is 10 power minus 12, and this is 10 power minus 2 already. So 10 power 6. 10 power minus 2 will be 10 power 4. Y cross X is known as minus Z, because X cross Y is the Z. So the correct answer finally is going to become minus of ये कितना हो गया, 10 power minus 8, correct, in the Z direction, and the unit of Force is Newton. Option number A. Minus of 10 power minus 8. Everybody, correct answer is option number A. Minus of 10 power minus 8 AZ newtons. Okay. Right. Okay. Moving ahead to the next question. This is the option number A, which is totally correct. Moving ahead with the next question. Two thin wire carry currents along the same direction. What is the force experienced by one due to another? Okay, now force between two thin wires. Okay, of course, when nothing is mentioned, so we'll take their length as infinity. So there are two thin wires. Have a look into this picture. Let us just consider this picture. Yes, guys. Now two thin wires, they carry the current along the same direction. It's a good question you can feel here. They are going to carry the currents in the same direction. Okay, suppose this carries the current I1, this carries the current I2, and both are carrying the currents along the same direction. Okay, let us for simply assume that this is the horizontal x-axis and vertical is the y-axis. Okay, what is the force experienced by one due to another? Now force experienced by a line charge, force on a line current element. Earlier question was force on point charge. What is the force on line current element? The force on the line current element is given by IL cross B. The line current element being IL. And B is the magnetic field due to some other source. Now what is the force experienced by one due to another? So let us calculate the force on two due to the another. Due to the another means, let us now here calculate force on the line current 2 due to the line current 1. Due to the line current 1, that force should be given by what formula? IL2, line current 2 cross the magnetic field due to first, cross the B1. Okay, now this should be equal to, ये हो जाएगा I2L2, right? I2L2. Now we only need the direction. Now try to understand the direction. What is the direction L2? देखो, what is the direction of L2 and what is the direction of B? पहले हम L2 का direction तो छोड़ दीजिए, पहले हम इसका direction ले लेते हैं. What is the direction of B1? B1 is in what direction? As I just explained you in the previous question, the magnetic field due to line current is in the phi direction. In one of the previous question, that is in the phi direction, azimuthal direction, and that phi direction is given by AL cross arrow. What is the AL? Okay, AL. मैं फर्स्ट लाइन की बात कर रहा हूं. द AL it is in the y direction as our reference. तो ये हो गया AY क्रॉस एरो. ओके, सो देखो ये जो AL1 है ना, ये AL1 है, that is AY, right? Then this is known as arrow 1. Okay, the perpendicular distance from the axis of first wire towards the point of observation, and this is moving along the x direction. ये जो perpendicular line है, that is moving along x. AL1 arrow 1. Okay, so this is x. What is y cross x? That is minus z. That is the minus z. Y cross x is known as the minus z. Okay, right? So now I can write down that the direction of this, what is the direction of L2? AL2. This is also in the y direction. So this is AY cross what? This is AY cross the direction of B, that is minus AZ. Right, y cross z is x, y cross minus z is minus x. Now what does it mean? The force on the 2 is along the minus x. Okay, the force on the line 2 is along the minus x direction. So this is the direction of the force. Okay, right. So what does this mean? This force is perpendicular to the lines, and what it is doing, it is attracting the second line towards the first. What it is doing? It is attracting the second line to the first. So it is option number B which is correct. Perpendicular and attractive. Got it, everybody? This is a nice decent question. It is perpendicular and attractive. It is perpendicular and attractive. Okay guys, this is perpendicular and attractive, right? अच्छा, if the wires were carrying the same current, or current same तो यहाँ पे जरूरी नहीं है, but where the wires are carrying the current in the opposite direction, then the answer will become C. Then the answer will become C, right? So let me mention this as a remark here. Okay, if currents were in opposite direction, if the currents were in opposite direction, then the answer would be C, that is repulsive. Perpendicular and repulsive. Okay, perpendicular, because इसका current तो fix है ना, so इसका current हमने fix रखा, so what is the direction of B1? That will be, what is the direction of B1? That will be minus AZ, but the AL2, I am changing the AL2, and that will become along the minus AY. So when you do this minus plus, y cross x will become plus x. Okay, plus x का मतलब क्या होगा? Plus x means that this is the direction of the force. So now it is trying to push the I2 away. It is trying to push the line current 2 away. Okay, so that means it will be repulsive in that case. Then the answer will be C, if the currents were in opposite direction. Okay, then it will be perpendicular and repulsive. Next question, guys. If the magnetic field intensity in a certain region is given to you, then what is the current density at the point? Current density at the point. One of the version, this is based on one of the version of what? Ampere's law, right? Ampere's circuital law, right? Or also known as the Maxwell's equation for static field, right? So you need what? The current density J, and the current density J is given by what? Curl of H. It is del cross H. So you need to simply find the curl of this vector H, and that too it is in the Cartesian coordinates. The screen is again off. I need to change the screen time, I think. Yeah, okay. So this is a simple question. You need to calculate the curl. So let's do it up, guys. Let's do it up. The curl of H, to J, which is known as the curl of H, and that will be given by AX, AY, the determinant AX, AY, AZ, del by del X, del by del Y, del by del Z, and then you have the X component is 0, the Y component is X plus 2Y upon Z square, X plus 2Y divided by Z square, and the Z component is given to you as 2 by Z. Just solve up this determinant. So this is going to be AX, del by del Y of 2 by Z is 0, del by del Z, यहाँ पे 1 upon Z square का differentiation will become minus 2 by Z cube, minus 2 by Z cube, right? Minus the AY component, minus AY, del by del X of 2 by Z and del by del Z of 0 is 0, plus the AZ component, and then you have del by del X यहाँ पे लेंगे, so differentiation of X is 1, Y का रहेगा 0, so 1 upon Z square minus 0, 1 upon Z square minus 0. Now you need to calculate at 1 minus 1 minus 1, substitute the value, guys, right? At the point 1 comma minus 1 comma minus 1, what is the value? What is the value? Place down this value. यहाँ पे minus minus plus हो जाएगा. The J is going to be AX into 2 minus minus plus X plus 2Y, X plus 2Y, so 2Y will become minus 2 divided by the Z cube, minus 1 ka cube, right? Y component is anyway 0, and then you directly come to the Z component, which is 1 upon Z square, which is 1 upon Z square, right? So solving this becomes minus 1 upon minus 1 plus 1, so 2AX, second is 0, plus AZ, 2AX plus AZ, 2AX plus AZ, that is the option number D. Simple, 2AX plus AZ, correct answer, option number D. 2AX plus AZ is the very correct answer, guys. It is a very correct answer. Where is that gone? just a second guys, we are here, 2ax plus az. Okay. The following four vectors are given in the Cartesian coordinate system. Which of the following vector field will not satisfy the property of magnetic flux density? Will not satisfy the property of magnetic flux density. Now what is one of the property of the magnetic flux density? The question is related with the concept del dot B equal to 0. One of the Maxwell's equation, absence of magnetic monopoles. Okay, so now del dot B, which is given by the formula, because it is Cartesian coordinate, to del by del x of bx component, del by del y of by, plus the del by del z of bz. Right. If I want to discuss for option number A, what is the divergence coming up? Del dot B, differentiation of y square with x, differentiation of z square with y, differentiation of x square with z, सब कुछ 0 है. Option number B, what is the del dot B? Differentiation of z square with x, x square with y, y square with z, सब कुछ 0 है. Option number C, del dot B, differentiation of x square with x, y square with y, z square with z. So this is definitely not equal to 0, and the del dot B should be equal to the 0. This is not equal to 0. Okay, and even if you go for option number D, del dot B, see, differentiation of y and z with x, 0. Differentiation of xz with y, 0. Differentiation of xy with z is 0. So ये total answer हो गया 0. So what is the only correct answer is option number C, which will not satisfy the property of the magnetic flux density. Right guys? Okay. Yes guys, as always the PDF will be password protected, and the password here I randomly give you the password for today's flux. Just we discussed the question on magnetic flux. So today's PDF, which will be in the Telegram group, password protected, and the password is going to be flux, FLUX. The password is the flux, FLUX. Okay, chalo. Please have a note of this password. The password is going to be the flux, where the PDF is going to be in this particular Telegram channel, gate/ESE by Rakesh Talreja. I shall share you the link also once. Just a second. You can directly join using the link also, I am telling you. Okay. Yes guys, once again a quick reminder, Mastering Gate Concept series for the upcoming gate preparation. Those who are very serious from now, yeah, maybe your friends, juniors, whoever are interested, you can update them, because you get the conceptual detailed clarity, complete subject analysis, problem practice, and also discussions of PYQ, and at the end live Menti quizzes, just to make it a little bit more fun based and interactive. This is the schedule. You can note down, you can also update your friends. And since you guys are from electronics, so for you the network theory session is there today, 10:30 p.m. okay, because today is what? Today is Tuesday, na? So Tuesday, Thursday, Saturday, Sunday, network theory by your favorite Sanjay Rathi sir. That is at the 10:30 p.m. That is at the 10:30 p.m. just on this same channel, just in few moments. Just in the few moments it is going to be there. Okay guys? Chalo. That's it. Okay. Yeah, so this is the workshop. Once again, let me give you the update regarding to this workshop that is going to be conducted on the BYJU'S app, BYJU'S Exam Prep app, and strategy to conquer, the detailed analysis of how step by step you can conquer Gate 23 by your favorite Abhinav Negi sir, who is an IIT Delhi alumni and having the 10+ years of experience in this industry. And this is going to be on this Sunday, 12:30 p.m. Okay guys, so bye bye, thank you, stay safe, take care. Tomorrow once again we connect at the same time, 8 p.m, where we discuss the part 2, EMT part 2. Okay, we'll have the EMT part 2 discussions tomorrow. Okay, So tomorrow we'll be focusing more on the questions of the nature of antenna, transmission line, waveguides, and etc. 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 Okay guys, see you tomorrow 8 p.m. Bye bye. Thank you. Stay safe and take care.